There's a geological threat hiding in plain sight, a silent giant sleeping just off the coast of the Pacific Northwest. Today, we're going to peel back the layers on one of the most powerful and honestly least understood fault lines on the entire planet, the Cascadia Subduction Zone. Yeah, when you picture the Oregon coastline, you probably think of this beautiful, serene, totally stable landscape. And for generations, people took that quiet for granted. They thought it was a sign of safety. There are no daily tremors, no obvious clues to the incredible power building up just offshore. And that's the whole paradox of Cascadia, isn't it? The silence isn't a sign of peace. It's the sound of pressure building. See, unlike other faults that kind of let off steam with small, frequent quakes, Cascadia is locked tight. It's just accumulating centuries of energy. And the story of how scientists figured this all out, well, it actually starts with a mystery, thousands of miles away. So our first piece of this whole puzzle doesn't come from geology. It actually comes from history, from a really strange event that baffled Japanese scholars for centuries, and it turned out to hold the key to everything. Okay, picture this. You're living on the coast of Japan way back in the year 1700. In the middle of the night, a huge wave crashes into your town, causing all this flooding and damage. But here's the thing, nobody felt an earthquake, not a single tremor. It was a tsunami without a parent, what they ended up calling an orphan tsunami. And back then, it just made no sense at all. And for centuries, that's all it was. Just this strange, unexplained footnote in Japanese history. It wasn't until modern times, really, that scientists with new technology and computer models went back to look at these old records. They started trying to trace the path of this mystery wave, backward, all the way across the Pacific, to find out where it came from. And in that search, it led them straight to the coast of North America, to a place where a totally different kind of clue is waiting, perfectly preserved in the mudflats of Oregon and Washington. And here's where the story gets really incredible. You've got this mysterious wave hitting Japan, and it turns out that at the exact same time, on the other side of the ocean, entire healthy forests of cedar trees just died, all at once. So the big question for scientists was, what on earth could possibly connect these two things across the entire Pacific? The answer was right here, in these ghost forests. Scientists looked at the tree rings, and they could see that these trees didn't die slowly from some disease. No, they were killed instantly. The land they were growing on suddenly dropped by several feet, which flooded their roots with deadly salt water. And that kind of sudden drop, that subsidence, it only happens one way, during a massive, massive earthquake. All of a sudden, the pieces just clicked into place. The ghost forests proved a giant earthquake had ripped through North America right around the year 1700. And that quake was so powerful, it generated a wave that traveled all the way to Japan and became its orphan tsunami. The history books and the geology finally matched up, solving a 300-year-old mystery. So now that we have the proof, let's look at the engine that's actually driving this whole thing. This incredibly powerful geological machine we call the Cascadia Subduction Zone. Right, so this isn't your average fault line. This is what's called a Megathrust fault, and it stretches for 700 miles, all the way from Northern California up to British Columbia. Out there, the oceanic plate, the Juan de Fuca plate, is diving underneath the North American continent. But, and this is the crucial part, it's not a smooth ride.
For hundreds of years at a time, these two massive plates just get stuck. They lock together. But the Juan de Fuca plate doesn't stop pushing, so the North American plate starts to get squeezed and buckled upwards. All of that incredible tectonic energy has nowhere to go. It just builds and builds and builds, like an enormous spring being wound tighter and tighter.
And the geological evidence shows us that this spring snaps, on average, every 300 to 500 years. The last time it happened, 1700, which, puts us right inside the window for the next big one. And this brings us to what is maybe the most critical and frankly terrifying part of this whole story, time. Because when that fault finally lets go, the chain of events happens so fast, there's almost no time to react. First thing is the shaking. A full rupture of Cascadia won't produce shaking for 30 seconds, like many earthquakes we're used to hearing about. No, we're talking 4 to 5 continuous minutes of violent shaking. Most buildings, most bridges, they're just not designed to handle that kind of prolonged stress. And then, the moment that shaking stops, a new clock starts. You've got maybe 10 to 15 minutes before the first waves of the tsunami hit the coast. That's it. There is no time for an official warning system to do any good. The earthquake itself is the only warning you're going to get. For anyone in a coastal town, the situation is just stark. Roads and bridges, probably impassable. Power, communications, gone. Evacuation to higher ground has to happen right away. And for most people, it's going to have to be on foot. Now, if you're in an inland city like Portland, you're safe from the tsunami. That's true. But you've got a whole different crisis on your hands. That long shaking can cause something called liquefaction. That's where solid ground near rivers basically turns to liquid, collapsing buildings and roads from below. And emergency help, it's going to be severely delayed because all resources will be focused on the absolute catastrophe at the coast.
All of which leads us to the final, and maybe the most unsettling part of this whole situation, the deep, profound uncertainty of it all. The long wait.
Think about it. We can track a hurricane for days. We get tornado warnings on our phones. For a megathrust earthquake, there's nothing. No countdown. The sky doesn't change color. There's no sign. Everything will look and feel completely, perfectly normal right up until the second that it's not. Look, the scientific consensus on this is absolute. Based on the ghost forests, the sand deposits from past tsunamis, those Japanese records, this is not a question of if. The energy is there, the system is locked, a rupture is simply an inevitability. And that is the ultimate unanswered question, isn't it? We have the science, we understand how it works, we know what's likely to happen, but knowing what's coming and actually being prepared for it, those are two very, very different things. The clock started ticking in the year 1700, and we have absolutely no way of knowing how much time is left.